Okay, Ionic radius, here we go. Alright, so this should help you guys for spring celebration week. And also you guys in high school, I think it's chapter 12 in honors chem. I could be wrong on that. This would help in the periodicity chapter overall. Okay. So in here in this video, we're going to review a little bit atoms versus ions. We know atoms make up everything. Atoms are the basic unit of matter. We know that. We know atoms are made of protons, neutrons inside the nucleus. Then you got the electrons on the outside. Ions, on the other hand, are electrically charged atoms. Why? Because ions gain or lose valence electrons. So again, you know all this already, okay? This is a little bit of a review. And we know that atoms want to achieve stability, and that's why they chemically react to form new substances. And again, all I want in science is a full outer shell. A full outer shell. Yeah, a full outer shell. Gee, if I could only have a full outer shell, then I could be a stable substance. FOS. So atoms gain or lose valence electrons in order to acquire that full outer shell. Okay? So within that realm, we've got cations and anions. Okay? And we talked about earlier in the year, cations are positively charged ions. Anions are negatively charged ions, and again we talked about it before. What do cations do? How do they get a positive charge? They want to lose valence electrons. In other words, they want to lose negative particles to acquire an overall net positive charge. Where does that positive charge come from? It comes from the positive protons inside the nucleus. And again, with this too, we said atoms are neutral, nucleus is positive. Ions are charged, positive or negative. Remember the saying back in the day? Atoms are neutral, nucleus is positive. Atoms are neutral, nucleus is positive. Why is the nucleus positive? Big concept because the protons are positively charged. Okay? And that becomes really important when it gets to radius. We talked about that earlier. I'll get to that in a second. So we're going to compare the size of cations, an atom with its cation, and an atom with its anion. So I choose a couple simple ones, then we're going to use that other thing over there, that piece of technology. You know, we're going to try to use that to kind of see different sizes of atoms, cations, and anions. So we'll start with the basics here. So first off, we have lithium, Li. It has 3 protons. It has an atomic number of 3 protons. So lithium has 3 protons. The atom. How many protons does the lithium cation have? Again, the atomic number, as our buddy said a little while ago, defines what the element is. Okay? So again, regardless, it has 3 protons. So there's 3 positive particles inside that nucleus. And again, we talked about, with atomic radius, forces of attraction. Where do we get those forces of attraction from? The positively charged nucleus attracted to the outer rings that are negatively charged. And remember with atomic radius, as we went down a group, we kept adding levels and levels of valence electrons. The greater the atomic radius, right, the smaller the Coulombic attraction. I'll review that when we get to the chart. So both have the same number of protons because that defines what lithium is. Here's the lithium atom. Here's the lithium ion. So we know lithium atoms or atoms are neutral. So if atoms are neutral, I've got 3 total electrons to balance out those 3 protons. Okay? And because of that, we've got 1 valence electron, 2 in the first level, 1 in the second. Here, I've got the lithium ion. And we know it has 3 protons. So its atom has 3 electrons. But if you remember before, in the nucleus, we've got 3 protons. First level's got 1, 2 electrons. So, got to open up another level. Here's your third. All I want in science is a full outer shell. A full outer shell. Yeah, a full outer shell. Gee, if I could only have a full outer shell, then I could be a stable substance. We know that in order to acquire a full outer shell, this one can either gain Gain 7? What the? No. They're going to lose 1. And when it loses 1, what just happened? We just lost a whole ring. Whoa! And that's going to be interesting. We lost 1. So now we've got 2 electrons total, because now we've got a full outer shell, and hence the positive 1 charge, because we got rid of a valence electron. So now we've got 3 protons in the nucleus for both. 3 electrons total, 2 electrons total, 2 valence electrons here. Okay? So because we decreased the size, we lost 1 valence electron, kept the same number of protons, the cation is smaller than the atom. Okay? So there's your data right there. So let's do a little replay. I'm going to put the replay up here. So here we go. Here's lithium, 3 protons in the middle, in the nucleus, positively charged. First level has 2. Second level has 1 valence electron. So again, from here out, here's the size. This is the atom. Once it loses 1 to become stable, what happened to our size? It went from here out to now here. Here is our new radius. Therefore, the size of the cation is smaller than that of its atom, because we lose valence electrons, we lose that shell. New size compared to old. So overall, the general trend is the size of a cation, right, is smaller than that of its atom. Okay? So that's the first example. So again, size of the atom, and again, I'll pretend to draw it here. Once it loses 1, new ionic radius. So an ionic radius is smaller for a cation than its atom. You're losing a level to achieve stability. Okay? And you're getting closer to the nucleus. And here's the other thing. You have a strong nucleus of 3 protons with only 2 electrons. So there's a high Coulombic attraction. Therefore, the radius decreases. More of a pull inwards. Less shielding and repulsion, less levels. Okay? All right, let's take a look at the other version of it with anions. So let's analyze fluorine. Let me make sure this pops up good on the video camera. Hold on. Climbing over a desk. Oh, okay, we can see that. Well, all right. Well, let's take a look. All right. So the fluorine atom, we now know fluorine has group 17. It's a halogen, has 7 valence electrons, wants to gain a valence electron to retrieve a full outer shell. But let's take a look at the atom. So now we've got 9 protons. 9 protons in the nucleus. So atoms are neutral, nucleus is positive. Atoms are neutral, nucleus is positive. Okay? Atoms are neutral, same number of protons and electrons, nucleus is positive. The nucleus is bigger. The ion of fluorine, we call that the anion. We know it gains 1 to have a full outer shell, because in that second level, which I'll draw, it needs to gain 1 valence electron to get 8. Now watch this. So again, we have the same number of protons. But now we've got 10 electrons. So here's my thing. Think before I draw. Think about the forces of attraction. All we did, we obviously have the same number of protons, so the strength of the nucleus is still the same. The positivity in the nucleus is still the same. So now we've added another electron. And we know that those electrons are attracted to the nucleus, but here's the thing, you have many electrons floating around the nucleus. What are they doing to each other? They are shielding and repelling each other. So you're adding an electron, right, to add to the mix to shield and repel away. You didn't strengthen the nucleus. The nucleus is still the same. So think for a minute. Strong attraction. You added something that is going to continue to shield and repel away. What do you think will happen? Predict. It will become slightly larger. You did not strengthen the nucleus. All you're doing is adding electrons, valence electrons, on the same level. So let's draw it out. So here's the atom, fluorine atom. Okay? So here, I'll draw it. 9 protons, right? First level, 1, 2. Second level, 1, 2, 3, 4, 5, 6, 7. We can go now. Hold on here. Here's the original size. here, outward. Here's the atomic radius, the original size. So now you see that there's 9 protons, here are your electrons. These guys are attracted to the nucleus. These are too, but the problem is they repel each other back out, allowing for this size. So now we decide to, given the ion, right, 9 plus, look here, we add 1 more electron out to here. So now we're going to put this out here. So instead of making this stronger, all we did was add another valence electron that wants to be attracted to the nucleus but gets drawn away. So what happens is the size becomes larger because you're adding another particle on the outside to be able to, to have it be shielded and repelled away from the nucleus. This stayed the same. Okay? You added something that repelled away. So therefore the anion, negatively charged ion, because we've got more negative particles than positive ones, it becomes larger. Okay? Because you added an electron which gets repelled away without strengthening the nucleus. Obviously you can't add a proton, then you don't have fluorine anymore. You have neon. So again, the general trend is anions, negatively charged ions, tend to be bigger than their atom. Why? Adding a particle that gets shielded and repelled away without strengthening the nucleus. Okay? Alright, so that's that. So in summary, the size of the cation tends to be smaller than that of its atom. Think why? When you lose valence electrons, you get that full outer shell. Where's that full outer shell? Closer to the nucleus. Here, right, you're not only gaining an electron, right, you're staying on the same level. Same number of protons. It's going to get larger. So anions are larger. Okay? So again, let's review again one more time. Think about it. Same number of protons either way. So watch this. So without the drawing. For review, lithium atom, here's the ion. 3 protons, 3 protons. 3 electrons, 2 electrons. You took away something that gets shielded and repelled away. Lose a level. What happens to the radius? Radius goes down. Ionic radius is less than its atom for a cation. Does that make sense? The nucleus is still the same strength. So then for an anion, for fluorine and fluorine negative, right, fluoride, which we'll learn, you've got 9 protons. 9 protons. How many total electrons? You've got 9 electrons because atoms are neutral. Okay? So there's a force of attraction between them. Throw in an extra electron. Same level. It's going to be a little larger. You didn't strengthen the nucleus. Okay? So anions are a little larger than their atoms. Now let's take a look at the chart on the smartboard up